block of code, which means that block of code technique that I have told in the morning session. So which means that if I use x underscore L square, let's say x base L square. So in order to use that x underscore open curly brace followed by L caret symbol 2 and close curly brace, which means that x subscript of L square. So you can see here it has been notated as x base L square. Okay, so likewise you can grow up to how many subscripts you want, how many superscripts you want. That's up to your choice. You can use multiple nested kind of code blocks, like x base L base n square. Let's say x base L base n square. So you are using double subscript, like x to the base L to the base of n square. So you can use up to this level, whereas in the word and all you have to use lot many insertions of equation and then you have to do it. So without using that, you can simply finish it by using the curly braces and the underscores. So that is a major advantage. And we have talked about the fractional part, how to print the fractional part. We have talked about slash underscore slash frac, which is nothing but the fractional. So we have talked about this also. I just give a recap for that. So for the fractional part, we have to use slash frac followed by it will be followed by the double curly brace openings and endings. So the first set of curly brace is for the numerator and second end is for the denominator. So this is what we have talked about. In the numerator and denominator, you can have whatever you want, like whether you need x square or x square plus 1, whatever you need, you can insert. So that's what here we had an example, that x square into x base L base j square divided by the y square plus x. So you can have a equation like this. So this is one type. And next thing we are going to talk about is trigonometric functions. Okay, so we have talked about the x square, the algebraic functions and all. We are going to talk about now trigonometric functions. So inside the double dollar symbol, I'm just using double dollar. You can use single dollar, and equations depends upon your usage. So I have told you the basics, what we have to do and all. Like now, so for the trigonometric function, what are the trigonometric functions we have is we have nearly 6. So which is nothing but the sine, cosine, tangent, cotangent, secant and cosecant. So for this we can have the keywords like slash sine, slash cos, slash tan, slash cot, slash secant, slash cosecant. For the cosecant we have SC. Okay, so not cosec, it is CSC. So you can see that it has been printed here. So here if you want to use sine theta, okay, let's say we have printed the sine. So for the sine function, I told you that we have a slash sine matter. So for printing the special characters like theta, gamma and several things are there, right? So in order to print that, we can use the special sequences like slash theta. So if you use slash theta, you can see that it has been printed as theta. So if you type in the Google, if you search in the Google like math symbols in latex, you can see about lot many websites that are referring to. You can use, even the overleaf itself has its own site, so you can refer that. That will be very standard. So you can see that they have given a list of special characters. Okay, so here we have used the slash theta. So if you want to use gamma, like it is, yeah, here it is. Here, if you want to use the gamma, or if you want to use the beta, so you have to use instead of theta, you have to use beta. So now, if you want to use gamma, you can use gamma and tan theta and cot phi, and you can secant omega. So no need to worry about like so you can see that it has been inserted in a very precise way, and even the gamma, the way the gamma is inserted here is appreciable, because this gamma, the lower part should be below the line. So how we are using the Tamil scripts and Hindi scripts, if you notice there, you can see that some of the scripts will go under the line and some of the scripts will go beyond, beyond the top line. So for these kind of stuff, that is also included with gamma. So here it has been accompanied by the lowering. So here you can see that the gamma, theta, and phi are being inserted in a very precise way. So this is one of the important thing. So instead of, what happens if you write instead of this SIN, what happens if you place very only SIN alone? So you can see that this SIN has been italics, right? So it is a it is a mathematical font actually. It is available, defaultly available in the Latex. So it will be, if you don't use any slash symbol and all, it will treat it as a normal text. If you give any normal text inside the math symbol, it will be treated as it will be treated as a normal text, and it will be treated as italic ways. So mathematical way it is represented. So in order to print any text that has been inside the that has been inside the mathematical mode, if you need to print any text, what you can do is you can use the function called slash text. Okay, slash text. If you use that way, you can say that and okay, what is the package that I have? Okay, I don't have math package. So for that we need to have math package, AMS math package. So if we use that, we don't have, yeah. If we use that, we can have that sign as a, a normal text. So for that purpose, we are using the text function. So this text function is available in AMS math. So I have discussed about this in the previous class itself. So we have for entering the, or for using the function slash text inside the math mode, you can use slash use package of AMS math. Okay, so here this AMS math will be used at several locations. I will talk about one by one. So first, okay, so as for now we have talked about the trigonometric functions. Now we are moving on to the integrals. So in many cases we are using the integrals for Fourier series and Fourier transformation in mathematics, in machine learning, in deep learning. In many occasions we are using that. So we have to understand what is the basis for the integral also. Now, so in order to print the integral is divided into many several types actually. One is the indefinite integral, definite integral, domain integral, double integral, so triple integral. These are all varieties of the single integral itself. We have closed curve integral also. So for let's see one by one how we can insert those kind of stuff. So now we are going for the indefinite integral. Okay, so for the indefinite integral, you have to use the keyword called slash int. Okay, so int for integral. So integral f of x into dx. Okay, I have told you about this too. So I have told you about this. The thing is, whatever the space you are giving inside the math function, it will not be accepted. So in order to specify, or in order to give any particular space, you can use the backspace, backward slash symbol. So here it has been treated as this backward slash followed by the space will be treated as the space bar. So here you can see that there is one space behind, one space is attached there. Even if I use a double backward slash, like slash followed by the space followed by the slash followed by the space, you can see that double space has been inserted inside the mathematical notation. So here you can see that the indefinite integral is perfectly rendered in the PDF. So you can see that integral over f of x into dx. Now, so what happens if we are using any definite integral? Let's say double integral, single integral over minus infinity to plus infinity. Okay, I have to write integral over minus infinity to plus infinity. So for this, I am going to use only the slash int, whereas for giving the lower limit, we are going to use the underscore. Okay, for giving the lower limit we will be using the underscore. So in the underscore, let's say I'm going to give minus infinity, right? So for minus infinity, infinity is going to be a special symbol. So if you use here, if you see in this chart reference, for the infinity there is a keyword called infty. So where it is, here. So you can see that infty. So here you can see that if we use yeah, slash infty to minus infinity to plus infinity. So here plus infinity. So here why I am using the block of code, here I am using the block of code, right? Why I am using this block of code is if I don't use this, minus alone will be considered as the lower limit. So it should not be the case. I have to include whole minus minus infinity. So entire structure I have to give. So that's why we are using the block of code. So here integral minus infinity to plus infinity over the integral of e power x square, let's say x power 2. So x power of power. So which means that in the x power we have x square. So x power of, that is a block of code, and inside that we are giving x power 2 followed by dx. So if we render that, we can get the integral over minus infinity to plus infinity e power x square into dx, which is nothing but the Gaussian distribution. Now, similar to the Gaussian distribution, not exactly the Gaussian distribution is. Now, next thing we are going to talk about is domain integral. So, domain integral is the specific case for this, for this definite integral, which is nothing but you can take this int followed by in the suffix or in the lower limit we have to add d followed by whatever the case. I'm just taking the e power x square into dx itself. So if I use this, I can get that domain integral, which is nothing but capital D at the lower limit. So now next thing we are going to talk about is double integral. So some people are not satisfied with their usage. What they will do is slash int for the double integral. They will use slash int followed by f of x into dx. But I am not satisfied with their usage. So they have given like integral over integral. Here there is a lot many space. So instead of this, we can use double int. So IINT. So you can see that it has been attached. So I'll just type it again so that you can identify what is the difference I am mentioning here. F of x into dx. So here you can see that the first one is the improper usage. Okay, this one is the improper usage, whereas the second one, which is nothing but double int, is a proper usage of implementing the double integral symbol. So you can see the double integral of f of x into dx. Okay, so this is what about the double integral. If you want to go for the double integral, so here, okay, notation wise it is not right. Dx dy, and here it should be y. The function should be dependent on two variables, dx dy. Okay, now back to the pavilion. So here we need to talk about, now we are going to do the triple integral. So for the triple integral also we have a special character called triple int. Okay, for the double integral double int, for the triple integral we have triple int. So f of x comma y comma z into dx into dy into dz. Okay, so here you can see that it has been over here. So for giving the lower limit and the upper limit for this individual integral, obviously you have to go for this scenario. Okay, obviously you have to go for this scenario, like having the minus infinity to plus infinity at the each integral. And if you go for the overall integral, like indefinite integral, indefinite triple integral and all, it is advisable to go for the triple int or double int. Double, for the double integral you can go for the double int, and for the triple integral you can go for the triple int. So next thing we are going to talk about is closed curve integral. So this is you might have seen this in the surface integrals. You might have seen this in the surface integral chapters of mathematics. So for that, what you have to use is you have to use slash OINT, okay, which is nothing but slash OINT. So the O stands for this O present in the integral. So that's why it has been mentioned as like that. C over the curve C, f of s into ds. So you can see that there's a closed curve integral being represented. Okay. So the one of the main advantage here in the latex is you don't need to worry about many things, like you just by changing the simple commands, by changing the simple keywords, you can move on to the next mathematical models. So that is one of the important thing. So we know that integral is the sum of the very minute things, right? So what happens if you go for the macro sum, which is nothing but the summation? So when you have to use summation, so in order to use a summation, which is nothing but the sigma symbol I am talking about. So for that, you can use the keyword called slash sum. Okay, for the sum over 1 to I is equal to 1 to 1 to n. So here what I am giving is this is the part for the sigma over I is equal to 1 to n. So which is here sum over the lower limit is going to be I is equal to 1, which has been specified by the underscore symbol. The upper limit is going to be the caret symbol followed by the n. What is the upper limit you decide there. So sum over 1 is equal to, I know that it is going to be n. So here you can see that sigma over I is equal to 1 to n, 1 is equal to n. So here you can see that inside the sigma it has been written carefully that the sigma in the down surface you have I is equal to 1, and the top you have the n, and followed by 1 is equal to n. So the only the main fantasy for the latex is its rendering. For the for the word it will take a time of 1 to 2 minutes to enter the entire equations, whereas here if you know the basics you can directly enter the mathematical equations. So this is one of the thing. So next important thing we are going for is going to be the matrices. So in the matrices, in the section of matrices, we'll be seeing a lot many types like box matrix. We have normal, usual. The usual, the parenthesis matrix. Even usual, we have determinants. We have V matrix and all. So okay, so starting with that, we usually start with the normal matrix. Matrix without boxes, without box. So which is nothing but you can use dollar inside the okay, anyhow you have to use the mathematical framework. So inside the double dollar you can use begin matrix. So you inside the matrix you have to enter the elements of the matrix. So this is the very basic thing. So inside the double dollar we are making sure that we are creating the matrix framework. So here we are talking about matrix without box. Okay, so let's say I am having 2 cross 2 matrix as 1 0 and 0 1 identical matrix, which is nothing but identical matrix. So 1 followed by 0, and I need to print 0 followed by 1. So this is what I have to print, right? So what I have to do is this corresponds to the first row, this corresponds to the second row. From the visualization you can accept, you can see that. Whereas for the latex, what you have to do is you have to give ampersand after each element. You have to give ampersand after each element except the last element of the row. Except the last element of the row. Let's say I'm having 3 cross 3. Okay, now that will be easy to give an explanation. So 0 0 followed by 1. Okay, now so here after the each element I asked you to put the ampersand. except the last element. For identifying this is the last element, you can give double slash, double backward slash. Okay, so similarly, next row. So 0 ampersand 1 followed by ampersand is followed by 0, and since it is the last element, you have to use double backward slash. So similarly here, the 0 ampersand 0 ampersand 1, since it is the last element, you are going to use the double slash. So you can see that the matrix has been inserted. Since I have given double dollar, it has been printed at the printed at the center. So if you use the single dollar, you can see that it has been inserted at the middle of the inline. So now here you can see that there is no box, the matrix box that we have, that we usually represent. So now, so this is how the n cross n matrix. So it is not mandatory that you have to go for the n cross n. So it is not mandatory that you have to insert a square matrix alone. Even you can use n dimensional matrix, n cross n matrix is possible. So as I said so. Now here, next thing is going to be the matrix with square brackets or square braces. So for that, we can use okay, again the double dollar symbol. For easy explanation, I'm using this begin. So for that matrix, you have to use the keyword called B matrix. Okay, you have to use the keyword called B matrix. So for the square braces, for the matrix with the square braces, you have to use the B matrix. So same thing here. So here the arrangements is not going to be the different, the same as we have shown seen previously. So each element followed by the ampersand, the last except the last element, the last element should be followed by the double backward slash. So you can see that this matrix with the square braces has been here you can see that it has been pasted with, or it has been printed with the square bracket. Okay, and one more thing. So each element, let's say this can be a question that can be arised here. Can we insert any fractional part or subscript or superscript? Obviously, you can. So using the fractional part, let's say I am trying to insert x square plus y square divided by z square. Let's say. So if we have that, you can see that it has been automatically rendered. So you don't need to worry about how it is going to be printed, whether it is subscript, superscript, and many things. Instead of having that tension, you can easily print it using those shortcuts. So now, next thing we are going to talk about is matrix with parenthesis square braces. So there are people who mention in the square brace, who mention the, who mention the matrix in the square braces, or some people mention it in the parenthesis braces. So for those people who mention it in the parenthesis braces, we can use begin of, instead of having the B matrix, they can have the P matrix. Okay, so the same content, it can be repeated here. So only thing is with the parenthesis matrix you can have, so here it has been printed, so you can see that the parenthesis has been inserted here. So this is as simple as possible. So you have to you can use like this. So for the square braces we have B matrix keyword, for the parenthesis braces we have P matrix keyword. And next thing is we are going to have the determinant. Okay, so we are concerned about determinant also. So determinant of matrix. So for that, the same we are going to use the same code, whereas instead of P matrix we are going to change only the V matrix. Okay, so which is nothing but the vertical matrix. So here you can see that determinant. Okay, so here again I am saying for the square braces you can use the B matrix, for the parenthesis braces you can use the P matrix, whereas that for the determinant you can use the V matrix. For having the determinant symbol, I mean determinant keyword itself, again, so the some people will write it with using the keyword called determinant. So let's say det of this, that's all. So slash determinant of this slash begin V matrix followed by the elements followed by the end of V matrix. Okay, here you can use the word slash dit as I told in the trigonometric functions and all I have told you, right? So the same scenario here. So now next thing we are going to talk about is in many matrix, in many matrix, we'll be using the dots for indicating that there are lot many elements in between the columns. So for that scenario, how we can use? So that is what the scenario is. Now for that keyword or for that matrices, we are going to talk about matrices with dots. Okay, for that we can use the keywords called C dots and C dots and V dots and D dots. I'll talk about each and everything right now. So now begin, let's say inside the mathematical mode, I'm going to write the matrix begin uh, B matrix. Inside that, I am going to use, let's say, 1 followed by 0 followed by, let's say, I don't know how many members are there, so I am using C dots, which is nothing but it has to enter the columns. So that's why it has been mentioned as C dots. Ampersand, last element is going to be 0. And next thing we are going to talk about is, and the next row we are going to same thing, 1 ampersand 0 ampersand C dots ampersand 0. So in the next line we don't want to repeat it again, so we have to use the vertical dots, right? So for that we are going to use V dots ampersand again V dots. And for representing the diagonal wise, we shall represent some dots, right? The diagonal way. For that, we are going to use D dots. Ampersand. So last column again, it should be a vertical dot. So slash D dots. And the last line, let's say 1 ampersand 0 ampersand 0 ampersand 0. Okay, so last line it cannot be. Here we have entered. Mathematically, I'm not saying, I'm just giving an example. Okay, let's say I don't think go for regular line. Okay, now, so now you can see here. Spell check. So you can see here this is represented using the C dot, and this vertical dots has been represented using the slash V dot, and this diagonal dot has been represented using the D dots. Okay, so this is how the matrix can be, the matrix with dots can be represented. Okay, so now next thing we are going to talk about is some miscellaneous functions like logarithmic, and we have square root functions and all, right? So we are going to look ahead with that. So next thing we are going to talk about some miscellaneous functions. So now for that we are going to use again, I am just using the double dollar. So now just if we want to use log x, normal log x, so that we can use log of x. So if don't think it is available in this package, so here you can see that lg of x. So in as a Okay, in paper writing, many of the people are confusing the log x with respect to the LG of x. So the LG of x is nothing but it is log x base 2, the binary. So we are using in the algorithmic ways, we'll be using this log x base 2, right? So LG stands for the log x base 2. Whereas log x, if we simply write it in the log x manner, it is nothing but log x base 10. So for the natural logarithm, we'll be using ln, so which is nothing but ln of x. We call it as ln, which is nothing but the natural logarithm of x. So the natural logarithm of x is nothing but the log x base e. So if you want to mention as log a base b, what you can do is slash log underscore of a of b. So you can see here log b base a. Okay, so here we have given the base is given as the underscore symbol. Okay, underscore of a. So instead of a, you can have any compound instructions like x square plus y square. Whatever thing you have, you need to have, you can have. Okay, so this is for the logarithmic notions. Whereas next thing we are going to talk about is square root or the nth root, let's say. So let's say square root of x square plus y square. Okay, so for that you can use the square. For using the square root, you can use the keyword called slash sqrt. Okay, so while typing itself, you will get the suggestion, which is nothing but sqrt, square root of. So as I told already, I am going to use the square root of x square plus y square. Okay, so this is one thing. So you can see that the square root has been completely completely went to the last. If you use only the x square, square root of x square plus y square, you can see that the square root is being changed. So you have to be very careful with respect to where you are closing the bracket. Okay, now at the next, in some occasions, we'll be using the nth root, right? So for in order to denote the nth root, the same thing, sqrt, square root of x square plus y square. Let's take the same example. If you want to use the fourth root, okay, for that you can go for the specifier command, which is nothing but the square braces. So you can enter the nth root at this position. So you can enter 4, which is nothing but the fourth root. So you can see that fourth root of x square plus y square. So instead of that, you can have nth root also. So for that nth root also. This is how the square root and nth root will work on. So okay, now next thing we are going to talk about is we are going to talk about the minimization and maximization problem. In many operational research paper, we'll be having the issue like we'll be having the minimization and maximization problem. So for in order to how we can implement it, so that is going to be a very big question, right? So in order to implement that, you can use slash min of. Okay, so what I'm saying is slash min of, let's say x belongs to, you have to write okay, right. Now assume this is going to be the problem that you have to display. So let's say minimize x belongs to n, capital N. So you have to minimize that x square, x square plus x cube. Okay, you have to minimize it. I'm just giving an example, rough example. So minimize x belongs to n. You have to, the function is going to be x square plus 2x cube. So you have to write it. So here for writing this, you can say, I can copy here and paste it here. So now, so as I told already, for the special characters, you have to use the slash. Now, okay. Now you have to use the hmm, you have to display this minimization function. So what you can do is slash min of slash min, which is nothing but the minimize, underscore will denote the statements that have to brought under the minimize min keyword, and there we have to denote x belongs to n. So which means that x you have to you have to insert a symbol that is equivalent to the e. So here you can see that I don't know where it is, slash in. Okay, now you can see here it has been it is here, so slash in. So now here you can use slash in n. So which means that minimum of x belongs to n. So what is the function? X squared plus x cube. Okay, you can see that it is printed exactly. So minimizing the function, minimizing the character, minimizing the x which is belongs to capital N for the function x square plus x cube. So this is how the minimum function and minimization problem. For the maximization problem, very simple. Instead of the min, you can use the keyword called max. That's all. Sorry, underscore. Okay, I forgot about the underscore. Now, here you can see that the max of x belongs to n, x square plus y square, sorry, x square plus x cube. Okay, so this is one thing. So next thing we are going to talk about is piecewise function. So in many occasions in the probability distribution functions and in the piecewise lines, when we represent, we'll be having to incorporate two to three equations in the right hand side. Even lot many equations also we have to write. So in that case, what we can do is we can use the so one package called AMS Math. Even I have told you about this. You can use that package and you can enter that. So we are now going into the piecewise function. So I have already so it needs AMS Math function, sorry, AMS Math package. So I have already inserted, so I don't need to worry about that. So what you have to do is, let's say I'm just going to write it as z is equal to 0 when if x is equal to 1, 0 sorry 1 elsewhere. Okay, let's say we are going to type that function. So double dollar z is equal to, so I have to input give, I have to give two equations at the right hand side. So for that we can use the keyword called begin cases. Okay, so we can use the keyword called begin cases. So here this okay, inside the begin cases you can give two things. One is okay, one is we have, as I told already, sorry, one if x is equal to 1 or x is equal to 0, let's say, and 0 elsewhere. So this is what I have to print it. So now how I can represent is this 1 and if should be separated. So that's why we are going to put ampersand here. And you know that this if x is equal to 0 should be printed in a textual manner. So I am going to use text of function. Okay, if will be in the text of function followed by x is equal to 0. So this first line is ended and followed by the second line is going to be 0 ampersand. So this will 0 and elsewhere will be separated. So again I'm going to use the text, and for the final element I have to indicate whether to go for the next line so that it can be given as double slash. So you can see that this becomes the piecewise function. So you can give what n number of equations here, so that doesn't matter. Okay, you can see that it is the bracket will be adjusted by itself, so you need not worry about that. Okay, so this is how we will be entering the piecewise function. So next thing we are going to talk about is derivations. Okay, so the derivations is like in many cases in the physics, and while typing the physics journal papers, even in typing the mathematical based journal papers, we'll be incorporating some of the derivations, like in the proof for induction, in the proof for contradiction and all. You have to insert lot many derivation. Even for the theoretical derivation you might need to add. So for that you can use the same AMS package you can use, and for that you can use the function called begin align. Okay, inside the begin align you can say, let's say, okay, let's say, 2 power cube is equal to 2 into 2 into 2, and you have to go for the next step. So here this is the first step. So 2 cube will be represented as a 2 into 2 into 2. So here you have to go for the next step. So before that you have to explicitly say which is the left part and which is the right part. So for that you will be using the ampersand symbol. So for that you can use the ampersand before equal to. So you can, now you can see that this is going to be the left part and this is going to be the right part of the equation. So now you have to go for the next line, so that you are going to use the double slash, and in the second line you don't have any left hand side, so you can directly use the ampersand. So ampersand will denote that you don't have any left part is going to be null, so which is equal to 2 into 2 4, so into 2. Okay, so next slide, ampersand equal to 8. Okay, this is possible when you have incorporated the, when you have incorporated the AMS package. So here you can see that this each step has been numbered with equation numbers, right? So in order to avoid that, you can use star, align star. So if you use that, you won't be getting those numbers. Okay, so and one more case, this is here you can see that 2.2.2. Here you can see that the dot is at the decimal part, right? So instead of having that dot, you can use slash c dot. Okay, if you use the c dot, you can see that the dot is been at the center of the number, center of the vertical center. So you can see that this dot is different from this dot. So this is the c dot is nothing but the multiplication dot, whereas this normal dot will be used for the representing the decimal numbers. So we usually often use c dot. Okay, so and here you can see the here it is represented as 2.4.2, so it should be made as c dot. This is how the derivation occurs. This is how we can use the latex for derivation, like you can use the align star. So now the thing is, in many cases, if you have written any equation, or if you have written any, let's say, any section, or if you have used any images table, so whatever you have used, you have to refer it in the text, right? So at that occasion you might need to label it. So that is what we are going to speak now. So now we are going to speak about label and referencing. Okay, now let's say this is going to be the section for label. Okay, some there is a text. Okay, here there is a the following. We have not given double quote. Okay, the following section. Here I have to. Okay, I will come back here. Represents the labels. Now I have to mention that this following label. Let's say. Okay, this is going to be the fourth section. So I have to represent 4 here. Okay, so but Here I have to represent 4, but it is I'm manually giving. So instead of giving it a manual way, we can automate this labeling. So how we can use that labeling is you can use the keyword called label. Okay, so inside that label you can type whatever the text you need. Let's say you are having section label. Usual representation of the labeling will be the section. For the section we'll be using sec followed by colon. For the equation we'll be using eq dot, and for several things, picture we'll be using fig dot. There are a lot many things. Okay, no need to worry about that now, so I'll talk about that one by one. So you are using the section colon label. Okay, so now here you don't want to put it as in a manual way, so you have to refer it. So that refer can be used, can be used using the ref function. Okay, ref of. So inside the ref of, you can see the, if you type entering the first three characters itself, you can get the suggestion, so which is for the cross reference. So if you type that, if you click enter, you can see that it has been updated here. Now, let's say you are going to give one more section here. Okay, let's say section cross reference. Okay, now here it is going to be labeled as section of CR. Okay, now you have to see that this should be here. In before this I have inserted a one more section called cross reference, so it will become 5. It has to be automatically updated. So you can see that it can be automatically updated while running a recompiling the command. You can see that it is automatically compiled up. So this is the beautiful thing in the latex, that you need not worry about once it has been generally implemented or generally written, you need not worry about the changes that you have made. Okay, so that is what the beautiful thing in the latex. And one more thing I need to one more thing I need to compare here. So you should not give any two equivalent labels. Okay, so if you are having any two equivalent labels, here also sec followed by the label, sec followed by the label, you can see that the error has been come here. So multiply defined. Okay, you should not give like that. This is one of the important thing. And next thing we are going to talk about is labeling the equations. Okay, now let's say uh, we'll take this case. This as a case, and the piecewise linear equations given in equation. So here you have to input the equation number. Okay, now I'll come back here. So you have given it here, so inside this, this should be given in a mathematical mode, so I am giving equation since I need the equation number also. So I am giving it inside. So now I have to refer this equation, right? So similarly I'm going to label it. So in this label, for the equation, as I told already, for the section, it should be started with SEC. It is not mandatory. I am giving a nomenclature. This is a standard structure usually followed in the latex. So EQ followed by the colon. Let's say this is for piecewise function, right? So piecewise function. Okay, now here what I have to do, I have cross reference, so using the ref function. So equation, for the equation I have to use eq followed by the piecewise, since it has been given as piecewise, so I can use piecewise. So if I refer this, it is automatically incorporated as equation 2. Okay, this is the generalized thing, and even you can use it for the images and tables also. We are going to see that label images and tables in the upcoming session. I'm just giving an overview. And in many occasions you have to use the abbreviations, like if in your system you have to use the abbreviations, right? So at that occasion you can even the latex has one of the very interesting thing to implement there. So for implementing the abbreviations, you have to use the package called glossaries. Okay, you have to use the package called glossaries. I'll just give it text about it. So use package of glossaries. Inside the glossaries you might have lot many things like synonyms and antonyms. There are lot many things are there. So apart from that, we are going to use the acronym. Okay, we are going to use the acronym package, sorry, acronyms specifier. So now what we have done is use package. The specifier we have given as acronym followed by the glossaries. So now let's say you are going to use one thing which is called as GCD. Okay, I'm going to use GCD. So in the preamble area, in that area you have to give the explanation about the new acronym that you are going to define. Okay, for that you can use slash new acronym. Okay, acronym followed by, in the suggestion itself we are giving the three curly braces, right? So what are those things are, if you say here, so the first is going to be user specific keyword, and second thing is going to be the actual abbreviation you need, and the expanded form. So for example, here we are going to take an example that new GCD, which is nothing but new acronym of, I am going to specify it as GCD, or I can say GC. Okay, let's say I'm just giving for my reference. So it is user specific. I can give whatever I need. So there, and after that in the abbreviation, you can give it like GCD, what it has to be, the abbreviated form of the thing. So which is nothing but GCD, and followed by the expanded form, the greatest common divisor. Okay, so this is the example, this is the common syntax. So this should be inserted at the preamble area. So preamble area is nothing but, I told you about this, before the begin document. So we have inserted here, right? So greatest. Okay, now here now, so whenever you define the acronym, the first time usage should have the expanded form, which is nothing but the greatest common divisor. Inside the bracket it should be have GCD. For the next usage you should not have any consequence, like you should not use the expanded form. So that is automatically taken care by the latex. So that is one of the things. So here, okay, let's say the GCD. Okay, so in order to I have to use GCD now. So I have defined the acronym. I have to use. So for that, you have to use the keyword called slash GLS. Okay, which is nothing but the glossary. So GLS stands for the glossary. So I have to use GC. That's all. Is found for the, yeah, found for the number. Now I have used the first one here, and next thing I'm going to use again. So GLS GC was found in the previous section. So here, while you have to note it down that here the expanded form should be there, whereas here it should not be in the expanded form. So if you see here, so you can see here it is not expanded. This is the form here, it is not expanded. Whereas in the section 1, the introduction section, it has been expanded. So if you, okay, if you delete this package, okay, without knowingly you have deleted this paragraph or this sentence, okay, without knowing that you have incorporated any abbreviation over there, you have deleted. So obviously what it has to be done, this has to be expanded, right? So it is automatically done by the latex. Here you can see that the greatest common divisor. You have not changed anything. You have just deleted the previous occurrence, but the latex automatically converted the first recurrence of the abbreviation in the expanded form. So this is the one important thing with respect to the abbreviation. And if we want to print that abbreviation, list of abbreviations in many schools and colleges, we have to print those abbreviations, right? Even in the legal documentation itself, we have to print that abbreviations. So for that, you can use the keyword called, you can use the function called print glossary. Here you can see that the print glossary, and inside that square bracket, you can use the type is equal to acronym type. So if you make it like that, you can see it has been displayed. Okay, sorry. Here there is one more thing to discuss with that. So apart adding the print glossary, you have to create one more command on the previous thing. So which is nothing but you have to give make glossary command. Make glossaries. So if you have to, for printing the acronym list of acronyms, you have to use the make glossary command after the in the preamble area, and then you have to give the print glossary of type is equal to glossary command. So you can see that it has been printed. So and here this 4, there is a one more addition here, right? So it is this 4 is representing the first usage of the abbreviation. Okay, it represents the first usage of the abbreviation. So if you use it here, you can see it has been changed. So you can see that, sorry, it is displaying all the usage. So in which page it has been used, third page and the fourth page it has been used. Okay, so it is displaying like that way. So you are not giving, or you are not giving any hard coding at all. It is automatically printing for you. So this is why this is one of the most added advantage in the latex. Okay, this as far as this label and referencing is concerned, that's all. And yeah, now okay, now we can have a short break of 20 minutes. So we shall meet upon by 2:45. Okay, so by 2:45 we shall start with the tables, and we can go for the images, and then if time permits, we can go for the algorithmic packages and all. Okay, I thought of planning to revise the IEEE transaction class. So let's see how time permits. Once it is done, we can go for it. So we shall meet again by 2:45. So is there any suggestions, or is there any questions from the participants? Okay. Okay, sir. Just a second. So there is a query from the participant that whether you have to give only the capital letters or capital characters inside the second braces. No, you can give whatever you need. It is not even the, I mean, the truth of this relation is not even checked by the latex. So you can see here I have given as arima. So this arima has been printed here. It is not checking the truth. It is going to get what we are giving as input, and it will going to print it over there. Yeah, yes. So the another question from the another question from the participant side is whether we have to print the glossary at the top, or we can go for the last page also. Yes, you can go for the last page, and you can go for the wherever you need you can print. Even you can print it at the middle of the page also. So no one is going to bother about that. Okay, thank you. Okay, I will share. Okay, there is a Okay, the list of references that I have given here, I will share this link with the participant circle. Okay.